So now we're going to focus on Cartesian equation of a line. Okay, so 8.2. So let's recall grade 9, y equals mx plus b. Okay, this is the equation of a line specifically in slope y-intercept form. Okay, m is the slope, and then b is going to be the y-intercept. Okay, we know that. We focused on that a lot. Now, as a recall, ax plus by plus c equals 0 is the equation of the same line. So that equals that. The only thing is it's rearranged to be in standard form. Okay, so up until now, we've always called this standard form. We're now going to call this the Cartesian equation of a line. Okay, as a recall, if we had y equals mx plus b, and we brought over the y, but I'm going to insert it there, we would have 0 equals mx minus y plus b. This is that standard form. This is that Cartesian equation because it's ax plus by plus c. Okay, the slope would be the a. In this case, it's not always the same case. Okay, the b would be like -1, and then the c would be the y-intercept. Okay, but depending on what these numbers are, like the m and the b, that's going to switch. That's going to change. Okay, so don't think that this is like the general form. It's just me showing you that we can rearrange the slope y-intercept form to get standard form. Okay, so the relationship between the slope and the direction vector. Okay, we kind of talked about this briefly yesterday. I embedded it into the left, but now we're going to do it formally. So we know slope is rise over run, aka delta y, the change in the y's over the change in the x's. Now, the direction vector of a line is represented by, okay, vector m equals a comma b. So here is the connection. If the direction vector of a line, so say vector m, a comma b, this corresponds to the slope of m equals b over a. Okay, remember, this is basically the x, and then this is the y. So this is going to be delta x, delta y. Okay, so for example, say we take this line and we pick it up and we drop it back off at the origin. What we're essentially going to get is we're going to get some point here, AB. So for the slope of 0, 0, AB being like 2 points, it's going to be B minus 0 and then over A minus 0, right? Those cancel, M equals B over A. That's where we get it from. Okay, so this is always the case except for when A equals 0, right? Obviously, if we have B over A cannot equal 0. That's a restriction. And then in that case, we'd have a vertical line. Remember, when A equals 0, we had the slope is undefined. Okay, doesn't make sense to calculate it. Now, note, the direction vector perpendicular, okay, talked about this yesterday, to AB is, say for example, we call this vector n, we can call this vector n. What we do is, remember, it's the negative reciprocal, technically. Okay, so for the negative reciprocal, there are 2 steps. Step 1, flip the number, right? Flip the fraction, flip the number. And step 2, flip a sign. Okay, so if it's positive, now 1 is negative, negative, 1 is positive. Okay, you only flip one sign when it's in this form, this direction vector form, because if you remember, if this is B over A, this is a solid number, and now this one is going to be A over, like negative A over B. So this number has to be negative. We only apply that negative. We only flip the sign of one of those numbers. Okay, I'll leave this up here. So, example 1, determine the equivalent vector and parametric equations to this line. Okay, so I'm looking at this, y equals 3 over 4x plus 2. Okay, so first, it's what can we pick out from this equation of a line? Okay, remember this is slope y-intercept. M is the slope, B is the y-intercept. So the information that we have from here is that the slope is 3 over 4 and the y-intercept is 2. Another way of writing the y-intercept is going to be 0, 2. Okay, so when we think about this, let's do vector equation first. Okay, vector equation. We're going to have vector r equals. We need a point, and then we need some parameter, and then we need a direction vector, okay, such that t is an element of the real number system. So our point goes in here, which is 0, 2. And then our direction vector, which is in the form, and remember it's the slope form right here, b over a. Okay, so it's ab. Okay, but this would be b over a. So we would get the direction vector 4, 3. Okay, and that's it. Now, parametric equations. Okay, we're going to go x equals and y equals. So let's take all of the x components. 0, so you can put 0 or you can just leave it out, plus 4t. And the y components, 2 plus 3t. That's it. Okay, I want to extend this a little bit. I want to show you the Cartesian equation, okay? Because I want to go over the steps for that again. Okay, so the Cartesian equation, I'm going to bring over this y here and set this equal to 0. So 0 equals 3 over 4x minus y plus 2. Okay, there are 3 rules for the Cartesian equation. Okay, so here are the rules. Number 1, we must write it in the form ax plus by plus c equals 0. So in other words, everything on one side, nothing on the other. Okay, nothing, that's 0. Now, number 2, the coefficient of x, so a, must be positive. Also, a, b, and c must be integers. Okay, so they must be element of the integer set. So, coming back over here, 3 over 4 is positive. Okay, now, what would we have to multiply this entire equation by in order to get an integer value for 3 over 4? Well, we can multiply everything by 4. Okay, 0 times 4 is going to be 0. Okay, 3/4 times 4, these would cancel out. We would get 3. So we get 3x. Okay, 4 times negative y gives us negative 4y. And then 4 times 2 gives us plus 8. So this would be the Cartesian equation for this line. Okay, and if you just think about this line, y-intercept is 2, positive slope. This is the line, y equals 3/4 x plus 2. We can also write this as vector r equals 0, 2 plus t, 4, 3. Okay, so now we're labeling these graphs with either or. Okay, example 2. For the line with the equation, and then we have some vector form equation here. Okay, determine the equivalent slope y-intercept form. Okay, so we know that this is our point, and then this is going to be our, give us information about our slope. Okay, so we have y equals mx plus b. This is the form that we want this in. Okay, so this 3 steps to find the equation of a line is find the slope. Okay, find m. So if this is a comma b, and we're thinking of the slope, we're thinking of b over a. So we're thinking of -4 over -1, which is just 4. So let's go ahead and sub in that 4 to where the m is. Okay, second step is to find the b. Okay, a lot of times what we do to find the b is we sub in m, x, and y, and all we have left over is b, and then we can solve. So let's sub this in for x and y. So we know we have 4 bracket 3, and our y value is going to be -6. So -6 equals 12 plus b. Bring this over. -6 minus 12 is -18. Okay, so we have b equals -18. And then step 3, rewrite the equation. Let's go with that. Rewrite the equation. So all we have to do now is rewrite. So I have y equals 4x minus 18. And that's the equation of this line in vector form, but this time it's in slope y-intercept form. Okay, now let's recall the slope of a horizontal line is m equals 0. Okay, what this means as a direction vector is since this is 0 over some number, where it's b over a, it's going to be in the form a comma 0. And then the slope of a vertical line is undefined. Okay, that means that it was like some b value over 0. So in other words, it's going to be 0 comma b for the direction vector. So example 3, determine the Cartesian form of the line with this equation here. Okay, so this is the vector form of an equation. The bracket with the numbers in it beside the parameter is always going to be the direction vector, okay, which is the slope. And now this is going to be our point. So in other words, let's talk about this slope, okay? So direction vector, I just put it D1, is 0 comma 2. So what that means, since this is a comma b, we know that the m is going to be b over a. So in other words, it's going to be 2 over 0. As soon as we see 2 over 0, we can say the slope is undefined. And what that gives us is a vertical line. Okay, if you think about a vertical line, any vertical line, wherever it is going to be parallel to the y-axis. Okay, as a recall, the equation of a vertical line is in the form and it's going to be in the form x equals x-intercept. Wherever it crosses the x-axis, So what happens with a vertical line, and I'm gonna just pretend this one right here goes through the point 1, 4. Okay, so 1, 4. Here's what actually happens with a vertical line, okay? And I'm gonna extend this here. So we have maybe the point 1, 7. Then we have the point 1, 6. Then we have the point 1, 5. This one is 1, 4. Okay, and it goes down and down and down. So this, like every single point on this line is going to be in the form 1, comma, and then some number. Okay, and this is going to hit every number. So what ends up happening is because it goes through 1, 4, that's where we get like x equals x-intercept, because no matter what, we know that this is going to be 1, including the x-intercept. So a general form to say this is simply by saying, oh, x equals 1. And that just means like, as long as x equals 1, we're good. And you also see this form when we label asymptotes, like vertical asymptotes. Okay, so just think of that as well. Okay, so let's recall the AB in the Cartesian equation, ax plus by plus c, so this a and b. This is a normal to the line, okay? And we name it vector n for the normal, okay? So vector n equals AB. In this diagram, the blue line, which is right here, is the normal because it's perpendicular to that red line, okay? And the normal goes through the origin. Okay, this is called the normal axis. If a line is drawn to the red line but does not go through the origin, then it's simply a normal. Okay, so that's going to be the difference between a normal axis and a normal. Okay, going through the origin versus going through any other point. Like this would still be a normal. This would still be a normal. This would still be a normal. Okay, as long as we're perpendicular to that red line, it's normal. Okay, Cartesian equation of the line in R squared. So in R squared, the Cartesian equation of a line, also we can call that the scalar equation, okay, is given by ax plus by plus c equals 0. Okay, where the normal is, where the normal to the line n equals ab. Supposed to have the accent there. Okay, a normal to this line is a vector drawn from the origin. Okay, again, origin here, perpendicular to the line given by the point NAB. Okay, so in this case, the original one was right here. So this is going to be normal AB. Oops, sorry, I meant here. Okay, remember the normal is a line as well, so the normal can have arrows on both sides. Okay, let's take a look at example 4. Determine the Cartesian equation of a line passing through this point A, which has the normal vector n at like 5, 3 as its normal. Okay, so there's two methods of how to do this, and we're going to split our page. So method 1, we're going to use the dot product. Okay, so we know that whatever normal we have, if we dot it with the point AP, we're going to get 0. Okay, here's the thing. We don't know what point A goes through, so let's just make up the point P, which is XY. Okay, so that means if we want AP, we're going to do P minus A. Okay, so we're going to go X minus 4, comma, Y minus negative 2. So that's going to be Y plus 2. And that's going to be our AP. Now, let's fill this in. N is 5, 3. And then we're going to dot it against X minus 4, comma, Y plus 2. Okay, and that is going to equal 0 because, again, the normal is going to be perpendicular to our vector. Okay, So I did put little bullet points here. So we just did this. We expressed vector AP as the difference between point A, which we have, and some arbitrary point xy. And now what we're going to do is use the dot product and solve. So we're going to have 5 times, right, because we multiply each x component. So x minus 4. We're going to have plus 3 times y plus 2. And as a reminder, the dot product is going to end with a scalar. So we're going to have a number, okay? And that's why we do a plus between these rather than a comma. So we have 5x minus 20 plus 3y plus 6 equals 0. Okay, so we're going to have 5x plus 3y. Those are not like terms, don't add them. And then negative 20 plus 6 is negative 14 equals 0. Okay, so this is one of the ways that we can find the Cartesian equation. 2, using the Cartesian equation. So what we're going to do is we're going to sub in a, b, x, and y into the Cartesian equation. Okay, so if we have ax plus by plus c equals 0, the thing is a and b right here we know is our normal. Okay, so just to recall, our normal is a comma b. A and b are the coefficients of x and y in the Cartesian equation. So we can go ahead and directly sub in 5 and 3. Okay, leave a couple spaces. Now, we also have a coordinate xy. Our coordinate is 4, comma, negative 2. We don't know c. Okay, so we have one equation, one unknown we can solve. So 5 times 4 is 20. 3 times negative 2 is negative 6. And then plus c equals 0. So 14 plus c equals 0. I get c equals negative 14. Oops. So, I jumped the gun here. Solve for c. And then what we're going to do is we're going to rewrite this equation with our a, our b, and our c. So our final equation is going to be 5x plus 3y minus 14 equals 0. Okay, so these are the two methods that we can use when we have a point and a normal. Okay, normals of parallel lines and normals of perpendicular lines. So let's talk about normals of parallel lines. So since the slopes of parallel lines are the same, their normals will be scalar multiples of one another. Okay, so essentially like their normals are going to be the same, just like on a different, like going through a different point. So this one goes to the origin, right? This normal, but this normal would also be a scalar multiple, and this one, okay? And then also, they're going to go down and down and down forever and up and up and up forever, okay? So again, if we have two parallel lines, L1 and L2, the normals will be the same. Okay, they may be scalar multiples of each other. They may be going in different directions, but this is what we want to focus on. Okay, normal 1 is going to be a scalar multiple of normal 2. Okay, now normals of perpendicular lines. So this time we're going to have L1, which is blue, and L2, which is red. So the thing is, L1 and L2 are going to have a dot product of 0. Okay, so what's going to happen is if we have, for example, we have L2 right here. If we have a normal that's going through L2, and then we have L1, if we have a normal going through L1, these normals are also going to be perpendicular. So the dot product of those normals are also going to be 0. Okay, so now let's put this into an actual question. Example 5, show that the lines L1 and L2 are parallel and non-coincident. Okay, so the normal for L1 is 3, negative 4. And the normal for L2 is going to be 6, -8. So what we want to do is we want to say that some scalar times n1 is going to equal n2. Okay, or some scalar of n2 is going to equal n1. Okay, it doesn't matter how you write it, that's fine. So what I'm going to do is I'm going to stack the x components and then the y components, and I'm going to see if they have the same ratio. Okay, so let's do 6/3, and that should have the same ratio as -8 over -4. Okay, in other words, we have 2 equals 2. So we can conclude that this is at least parallel. Okay, that's the parallel symbol. Now, in order to check whether or not it's coincident, so this one's saying to check that it's non-coincident. Coincident means that they're the exact same. So coincident is like exact same line. So what we've done is we've checked the normals. Now we're going to venture out to that C. Okay, so the normals, we stacked the second one divided by the first one. Okay, so what we're going to do is we're going to check the C value. So we're going to do the same thing. We have to keep it consistent. If we're always dividing L2 divided by L1, we have to do the same for the C's. So we're going to go 12 divided by -6, and then this is -2. So let's take a look at these. Okay, 2 does not equal -2. Therefore, these lines are non-coincident. Okay, they're not the same lines. It's essentially kind of saying that these values, they're going to go through a different y-intercept. Okay, so just as a little bit of a recall, we're going to have some line. If we think about the slope of this, we're going to bring the 3 over, divided out by -4. We're going to have 3/4 as a slope. Okay. Oh, we didn't even have to do that because we can just look at the normal. That's okay. 3/4 is the slope and 6 is the y-intercept. So that's going to be L1, and then this is going to have 12 as the y-intercept. Oh, that's 6 divided by -4. Okay, so we're going to be up here. That's fine. And then we're going to have -12 divided by -8. We're going to have positive as well. So say we have 2 lines. We want to ensure, so that's L2, we want to ensure that they're going through different y-intercepts. Okay, all I was doing is rearranging this into like a y equals mx plus b form just in my head, just so that I can like quickly sketch this. But if these C values had the same ratios as the normals, then they'd actually be coincident, which means that the line would lie on top of the, like one line would lie on top of the other line. But in this case, that's like not the case. The case is that they are non-coincident. They're not the same line. So B, for what values of K are lines L3? So we have Kx plus 4y minus 4 equals 0, and then L4 is 3x minus 2y minus 3 equals 0, okay? Perpendicular lines. So we have 2 lines. They're given to us in our Cartesian form, okay? And we want to know when they're perpendicular. So this K value, that's going to be what we're going to be solving for. So we want to focus on the normals. So let's go normal 3, which is K comma 4. And then normal 4, which is 3 comma -2. And in order to be perpendicular, the dot product between these two must be 0. So n3 dot n4 must be 0. So let's go ahead and sub these in. We're going to sub in k comma 4 dot 3 comma negative 2. Okay, so k times 3 is 3k. Okay, 4 times 2 is negative 8, and then equals 0. Okay, now all we do is go ahead and solve for this. Okay, bring the 8 over, divide by 3. We get k equals 8 over 3. So when this question asks for what values of k makes these lines perpendicular, it's when k equals 8 over 3.